Okay, let's start. So today is all about exercises. So I'm not going to ask who we did it or not. I don't care at this point. No, I'm kidding. I care, but it's on you. I mean, it's better to practice as much as you can. If you just wait for me to give you the answers, you don't learn as much. Plus, I figure since the exam is coming, you should start feeling the heat a bit. By the way, I haven't started yet writing it, so I don't know. Oh, did I post last year's exam on the Moodle page? Yeah, okay, great. I posted some exercises, but I don't remember if I posted. Yeah, okay, all right. So this gives you a taste of the kind of thing I may be asking. Of course, it might be different. All right, so going back to now, we're not in the exercises yet. We're talking about the exercises at the end of chapter 5. And we were here. And by the way, this, I'm not sure it's right or wrong. I have to compute it. So just to keep you, put you back in the mood of what we were talking about. So we had two marginal abatement costs, MAC1 and MAC2. And as you can see, it looks like firm 2 has an easier time abating its emissions than firm 1. So how much will each firm emit if they don't make any effort at reducing emissions? Question 1. Well, for that, you just take 20 divided by 1 is 20, 10 divided by 2 is 5. So that's the dirty little trick that you can use. Of course, where does that come from? It comes from here. So you set MAC1 to 0 and you find that E has to be equal to 20. You set MAC2 to 0 and you find that E has to be equal to 10 divided by 2, so 5. But so if you just you're in panic mode and you don't remember how to where you compute this, just do 10 divided by 2, 20 divided by 1. That's how you find it. And then, so this was a neat little question that I asked here that one of you found. I was very happy. So this was the answer was E1 equals 10. We won't go back on that. And then find the aggregate abatement cost curve. So this is the challenging one. Because what we must do is to add up the emissions this way. So ask, for instance, at a level of marginal abatement cost of 10, then how much would each firm have emitted? So that gives you the sum total of the abated emissions. So then the first question, of course, is at MAC of 0, what would be the total emission? Well, we already know it's 20 plus 5 is 25. And then the tricky part is to adding these two curves together. The first thing to note always is that, so you look at where the highest curve starts. Here it starts at 20. The other starts at 10. So it means that between 20 and 10, if you are asking for firms to abate until they have a marginal abatement cost of 15, for instance, that firm has already no emission whatsoever. So all the remaining emissions are for the firm number 1 here. Good. All right, so then what you have to know is between 20 and 10, the marginal abatement cost, the aggregate marginal abatement cost is exactly the same as just this abatement cost curve. So it's MAC1 of E. So MAC of E equals MAC1 of E. So it's 20 minus E. But then the crucial point is when the second starts abating, or starts not abating, so starts emitting, so it's below 10. So to know what, so this, it's 10. to know this value, what you must do, well, you must look at, so where is MEC1 when we are at emissions of 10? So you compute MEC1 of equals to 10. So you find out that E1 has to equal 20 minus 10, so 10. So here this is 10. Oops. And here, how do we find this part here, which I don't know if it's right or wrong. We'll check it later. Somebody remembers. Was it? No, just a twitch. Somebody in the chat, please help us. So there's one person. Albert, please help us. No, no clue. Well, what I have to do is to add this curve to that curve. So I'm not going to say it's MAC equals, oops, I hate when it does that. There's no way to get rid of it. You can never say, you can never add prices in this instance. What we add is quantities. So how do we do it? Well, we don't do MAC equals MAC1 plus MAC2. What we do is we must invert the curves. Oh, yeah, maybe if I go back to this. Okay. So step one, you find the inverse MAC function, which is just like when we have demand functions, when we start with invert demand function, then we go back to demand functions. Then you add them together, and then you flip them back. That's it. You invert your MAC functions, add them up, then flip them back. You could do it in other ways, but I would like just to always tell you it's the same way, so you learn it and you're good to go with it. So that's the way to do it. All right, so let's see if I can do it. So I have that MAC1 is equal to 20 minus E. So inverting. So to find the last so inverting, this is quite big. One invert MAC curve. I have MAC1 please don't look at my stuff, but don't worry, I haven't written the exam yet. So MAC1 is, was 20 minus B. So I find that, so I just flip these two together. So E1 is 20 minus MAC. And then I have MAC2, which is 10 minus 2E. So let's flip this. Get here. So 10 divided by 2.5. And then here this is 0.5. Right? And now that I have quantities and quantities, so this is quantity of emission, not price, then I can just find that I just aggregate the quantities. So I find that um, 25 minus 1.5 then 3 invert back into aggregate. So you get equals this. So fine. 25 divided by 1.5, that's 3/2. Yeah, that's so there's nothing I can do with that. Why did I do such a thing to myself? So what did I have here? Oh yeah, that was all right. Okay. 7 minus, and then so 1/, so that's 2/3, so 0.7. Is that what I had written? Yeah, good. So this is how you do it, and then let's just to put back that we have, but yeah, this is really to help you to tell you what's a function of what, but you see that in the middle you're just flipping the thing. So one is the function and the other is function of one. All right. So what is the so how you would answer this is you would say so final answer, yeah, MACF. So this equals 20 minus E for um, 0, 10, and it's equal to minus 2/3. For and then that's 10, 25. And you could even add, but I'm not going to be mad if you don't. So it's equal to 0 for emission larger than 25. Also, something else that is not so you shouldn't waste too much sleep on is how you write these limits there, if you include the equal or not. So how do I do it? Generally, I would say that positives include the 0 and the negative don't. So maybe I should, yeah, I should write it this way, but it's really, this I'm really not going to care too much. So as long as you don't overlap, but this is really a mathematical thing. It's just to prevent questions if somebody is going to have, but as long as the intervals look okay, I'm happy. Okay. So that's in this curve. Oh yeah, now through. So questions about this? Also, it's really if you are completely confused, then my advice to you is learn this step by step, and it's just going to be fun. So it's a really mechanical thing that you have to do. Of course, it's harder when the intercept here is different. So here we have 20 and 10. If we both add 20 or both add 10, it would be super easy. You would just do step 2 for the whole MAC curve. But this and also, why do we lose so much sleep on this? Isn't this environmental economics curve class? Why do we do so much math and stuff? Well, the point to highlight here is look at this, how the curve looks. Well, we started with two firms that had linearly increasing marginal abatement costs, and yet we ended up with a curve that looks like this. This is for two firms, but you can imagine if you have 3, 4, 5, it would look more and more convex. What does that tell us? Well, it tells us that, again, having an emission level of 0 might not be the best, because you're going to always find some firm somewhere that just has a terrible technology, and it costs incredible amount of money to abate. So you're going to have some sliver of emissions there that is just going to be so expensive to abate. And so this is a general phenomenon that you observe, that the more and more you try to reduce pollution, the harder it is to catch the last piece of it. This applies to anything. So think, for instance, plastic in the ocean. You can get rid of most of it, maybe, but then good luck extracting every molecule of plastic you find in the ocean. I know there was absolutely 0 molecule of plastic in the ocean 100 years ago. Tough luck, now we have it, and it's just there forever. Not forever, but for a very long time, because it would be impossible to get rid of it. So that's the message that this conveys as well. All right, so let's go to the next question. Okay, so this is what we just did, represent graphically. And note, by the way, that I started with the graphical representation. This, just visually, you see what's going on, and you don't make mistakes. If you start just computing stuff, it's very easy to get confused. But if you build your graph nicely, it's easy to not get confused. Okay, 5, find the optimal level of emissions. And then 6, at this level, how much will each firm be emitting? So let's do 5 here. I give you I think most of you will get it wrong, but still try it, and then if some of you get it right, I'm happy. Just want you to think a little. Does one of you think they are on the right track? Or have an answer to propose? I'm going to give you a hint. It's in the question. No clue. So the answer was there all along. It's 5. It's just a coincidence. All right. So yes, maybe you didn't find it, but so what should I try to do? Yes, good. So the optimal emission. All right. So but what's the problem there? Well, usually MAC, you have a nice, clean, normal looking formula and MD2, but here it just looks like a mess. And of course, the challenge is to know what to do with that. So yeah, and actually before last year, I had a difficult way of doing it. But now, last year, some smart student suggested to me a very neat way of doing it, and I'm going to convey it to you. So that what's going on there? Well, you just look at this, and where's the, well, let's just draw the, actually, if you just draw it well, it's very easy to do that. So it's 3E. But the thing is to draw it well is to answer to answer it. So let's have this in red. So it means that if I go to E by 1 unit, here the scale is the same, so I should go up by 3, right? So it should look like this. So this gives us a good clue as to where we should be looking. So we should be looking on this segment right there. So this is. So if your drawing looks as nice as mine, then it's just super easy to do. But so, of course, the thing is you have to draw this well. And so imagine you're bad at drawing and you want to know where you're at. So here's the trick. The trick is, so should you use this section of the curve to find the MAC equal MD, or this section of the curve? Well, all you have to do is ask yourself, so am I on this side of 10 or on that side of 10? If I'm yeah, at 10 I'm on yeah, so what you have to look is, if I compute MD of 10, will I be above or below? So if I'm above, I know that this is going to be on the left side, and if I'm below, I know it's going to be on the right side. Here you see that if you compute MD of 10, you get 30. Oh yeah, so let me draw it well. So this 10, 20, 30. So that should be here exactly. So you compute MD of 10 and you find 30. So you know, oh, this is, so it means that probably I'm too far away. So I'm on this side of the graph. So let me use that side. But if you found something like this, MAC of 10, you found it's like, so that would be 5, so 4. So in that case, you know that, oh, you should be on the right side. Okay. So let's just, so the tricky aspect, which segment of the curve should we use? So the trick, compute MD of 10, because I know that 10 is the critical value there. So if MD of 10 is above MAC of 10, if MAC is smaller than MAC of 10, then we must use the second segment. Higher. So let's do that. Um, 10 equals to 3 times 10 equals 30. So you know, should first segment. So MAC equals FE. Here, this is this segment there, 20 minus C equals 3E. So for E equals to 20, so E equals to 5. And we can see this is optimal emissions. But maybe I should, if I shouldn't use a star if I use it for market equilibrium, since it's not necessarily market equilibrium, but so that's the gist of it. Okay, so questions about this? All clear? If you copy it. So this is by text, but if you look at the image, then there's, as we see, image is worth 1,000 words. And it's pretty obvious what's going on there. So here MAC of 10, MD of 10 gives me 30. So I know that I should be on the left here. So this one, so I should use this segment, not that segment. Again, you have, don't thank me, thank a student in the fall semester who came up with this nice trick. All right. Last question. At this level, how much will each firm be emitting? And sadly, that's not 6. The answer is not 6. Let you think for a while, and then when somebody knows the answer, you can tell me. Yes? 15. How do you know it's 15? 20 minus 5? Why would you like, would you do that? Oh, so was it emitting or abating? Yeah, so I said it emitting, but so emitting is 5. But yeah, that's so if I said abating, that's exactly it. So firm 1, so firm 2, first of all, abates everything. So we are here. So firm 2 is at 0, has been at 0 for a while. And firm 1 does all the emitting, so it's 5. And we can say then that so firm 2 abates 5 minus 0, so abates 5. And yes, as you just said, firm 1 abates 20 minus 5. I could do other stuff, but yeah, that's good enough as a first pass of an exercise. Okay, so now if you don't mind, we can go to some exercises. Which one should we do? Maybe let's go with the first big exercise I posted. It's a nice one. So I'll be posting this on handle, don't worry. Which is, yeah, don't look at my stuff. Back on. All right. So yeah, it's written fall 2021, but yeah, it's the same. So yeah, let's start with one. So assume that the demand function for an environmental good is fully coincidental with the marginal social benefit. What does that mean? It means there's no extra external benefit aside from what the person who buys it gets. So that's pretty easy. But of course, there might be costs. So here we go. So marginal private benefit of Q equals marginal social benefit of Q. So it's equal to 60 minus 3Q, where Q refers to the quantity of the good. Assume that the supply function can be described by MPC of Q equals to Q, and that the external costs are always half the marginal private costs. So here we have external costs. So we have bad outcomes that affect other people. I didn't say what because I was lazy. I just say you have external costs. One, determine the equation of the marginal social cost, MSC. So go ahead and do that. Yeah, I think I'm going to try and copy all of this. Okay. So somebody has an idea? That one is not as hard as the other. Yes? It's possible, yes, but we're at A. Yes. So I'm confident that your next solution is good. Yeah, that's what happens when you copy latex. You get all these nasty things. Okay, so A. So yeah, so the marginal external cost is it how I write it in class? Yeah, marginal external cost. Q goes to the marginal private cost. Right, 2, so it's equal to Q divided by 2Q. So the marginal social cost is equal to the marginal private cost plus the marginal external cost. That's equal to 2Q plus graph the function and algebraically determine one, the market equilibrium, output and price, and two, the socially efficient equilibrium, output and price. So for this, we need more space. Okay. So this practice, there's a big chance I ask you to do something like this, and it's for your own good. Because if I just ask you to answer the questions without graphing anything, I'm sure half of you are not going to draw anything and not get the right answer. Okay, so 3Q. Okay, this is. Yeah, I don't have my solution. So 6T minus 3Q equals, so if this is 0, then this equals to 20. Oh yeah, I know. So let's place here. And then 60 would be there, so 20 is here. Yeah, maybe that's not the best idea, but I'd like to have the scale the same, so it's and then so that's marginal private benefit and marginal social benefit. And here, Q and 2Q. So the neat thing is now I can just use the squares. So and then it's super easy to just see graphically what's going on. It's like cheating a bit, but yeah. Whatever it takes to find the right answer. So 2Q is this, 3Q will be this. Yeah, it's going to look a bit crowded there, but who cares? So that's Q, that's the price, P. And that's, let's change color for that one. Let's use purple. Always put what you have on the axes. And so this is marginal private cost of Q. This is marginal social cost. Q. And this is marginal private benefit. Q equals marginal social benefit. So once you have made a nice drawing, then everything is super easy. Market equilibrium and socially efficient equilibrium. So let me see here. Okay. More or less. Oh, so I can, yeah, it's good, though it was intentional. Now I can just compute everything here. So what did you find? Yeah, for private or social? Private. All right. So let's start with private. MPC. Um, so I get MPC is 2Q equals 60 minus 3. So I find that. So that's 2 plus 3, that's 5. 5 divided by 6, that's 12. So Q star goes to 12. And the P star goes to 24. Is it the right answer? I think. So that's private equilibrium, social equilibrium. So efficient equilibrium equals this. So that's equals to 10, and the price equals to, so 10 times 3, that's 30. So we can draw stuff. So that should be 12, that should be 10, that should be 24. So that's not the difficult part. If you know how to solve a system of two equations, two unknown, that's decent. So we can interpretation. There is a negative externality. The market, free market, will not take it into account. And will generate or result in quantity exchange in a larger optimal. And a private price that is lower than the real social cost. So that's what's going on here. So we have an external cost and we should stop at 10, but then we produce, we just let people do what they like and they produce 12. So the private cost is 24. If we didn't have an external cost, then 24 and 12 would be perfect. Problem is we have this externality there. So then at 12, the real social cost is actually quite higher. And so that means that we produce too much. So we should reduce. Okay. see. So I let you think a bit about it. So calculate the total social benefit. Oh, wow. Yeah, that's unconventional character. Total social cost, total social surplus. So just to see if you remember. And then the dead weight loss. So this is the sort of thing I may ask you to do at the exam. So I think it's reasonable. Yeah, people at home, I mean, 5, so they can help us, so nobody. So somebody has a beginning of something. This is really just applying the definitions, but the tricky part is that we usually have, yeah, so we usually compute, for instance, the surplus at the market equilibrium, and that's simple. Here it's something that's, so if you think about, for instance, the total social surplus, but at the inefficient level, then you just have to know what you are computing. Yeah. Not too impressed by people at home. Maybe they're still in their pajamas at 2 o'clock. Okay, I should start answering some questions. You see whether you got it or not. Okay, so total social benefit. So the total social benefit is the integral of all the marginal social benefits between 0 and the quantity that I choose. So total social benefit of n, which is the, yeah, do I see it start at the market equilibrium and then this, okay, so let's start at 12, market equilibrium, so that's here. So it's equal to this trapezoid over there. So that's 12, that's 60 plus 24, yeah. Times 12 divided by 2. And that gives me how much? I'm going to need, oh yeah, what I can do is compute my things. So 504. Hope I'm not making mistakes. I'm too lazy to check my solutions. Total social cost. So that's this triangle there. But of course, the thing is we don't know what the value is there. So what we're going to do is say it's 12 times 3 times 12, which is this level there, which is actually 36. Like I could draw it already. So that's this whole triangle over there. Divided by 2. Um, so 260. Yeah, so bring a calculator at the exam, just in case. Oh, by the way, so the third exercise of this thing is horrendous in terms of numbers. I don't know how I got there, but that's for those. Has somebody tried the number 3 of this set of questions? It's a big mess. Sorry, I was trying to get like plausible numbers as to the size of parks and neighborhoods and stuff, but yeah, it got real bad real quick. Anyways, we're not there yet. So the total social surplus at 12 equals to 504 minus 260. So that's, do I do that? No, I'm too. 288. By the way, maybe so if I'm making a mistake, tell me or if nobody sees it. Anyways, I'm going to check with my other calculation to make sure I didn't make any mistake. Okay, so that's at 12. Now let's do that again at 10. So hopefully it should be bigger. So that's 60 plus 30 times 10 divided by 2. So that's yeah, 450, I think. That's 12, that's 10 times 3 times 10. divided by 2, so that's 150, I think. So that's easier. Yeah. Sounds good. So what we see, well, we see that if we stop at the socially efficient quantity, we get a higher total social surplus because we get this old triangle there. Whereas if we continue, oh sorry, we get this old triangle there. Whereas if we continue to produce, then here the marginal social benefit is this, but the social cost is this. So you see that here, the marginal cost is higher than the marginal benefit. So this is going to be the deadweight cost. Deadweight cost. So you can just compute. So it's 300 minus 288. So that's 12. But let's see if we can get the same answer with this. So also, it should be this triangle there. So let me just... So that's 36 minus 24 times 12 minus 10 divided by 2. So you see that what I did there, this is 36 minus 24. That's the base. The height is 12 minus 10 and divided by 2 because it's a triangle. And I should get, this is 12 times 2 divided by 2. So that's all good. All right. Stop me whenever you have a question. If you don't stop me, I assume you understand everything, or I lost you a couple of minutes ago. So there's nothing I can do. Okay. Is it possible to correct this externality? How? Justify your answer. Well, I didn't. So this is really something that you must compute. Here it's about what you have heard in this class up to now. But so what kind of words did I tell you when I told you about using government intervention to alleviate environmental problems? The economist way. So the Greenpeace way would be to go out there in the ocean and spray the enemy ship with fire hoses or something. But if you're an economist, what sort of intervention would you recommend? I'm not saying it's bad, so it's super efficient in some ways, but so the goal here is, of course, to reduce the quantity. So we should, yeah, so we should have something that discourages transactions on this market. So any idea? Yes, a tax. good old tax. I know it's unpopular and many politicians have lost their bid at prime minister because they propose taxes, but here we go. So taxes. And by the way, of how much, just to see if we can anticipate a bit what we're going to, how much would the tax need to be? Marginal tax rate. There is a right answer. Oh, maybe it's not that easy to compute. Yeah, it's feasible to compute it. So 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 I'm not necessarily asking for the right answer right away, but just to see what if you have an intuition of what we should do. Well, it's normal. You have seen taxes very briefly last semester. So what taxes do is they introduce some wedge between the value that consumers must pay and the value that producers receive. And what this wedge is the payment to the government. So typically, I'm going to pay, say, $12, but then $2 goes to the government and just $10 goes to the company. So it's the same whether it's consumers who must pay the tax or the company that must pay later. In the end, it's the same thing. So what should we do? Well, we should have a tax that is exactly, oh, yeah, go ahead. A bit higher, I think. Yeah, so let's go ahead and do that. So unit tax, I'm not going to say half of what because I haven't computed it. So goal is to make sure that the efficient, social efficient quantity is reached by the market vectors and ethics. So what we want is this, right? Yeah, now I'm totally freestyling. So what is it that I should do? Yeah, I'm here, right? Hmm. Okay, yeah. So what I want is this. So this is the, oh, yeah. So this is the private equilibrium, 2Q equals to 60 minus 3Q. But then I'm going to introduce a tax there. So it's going to be 2Q plus the tax rate paid by the producers must equal the private marginal benefit, which is equal to the, so, so 2Q plus the tax rate must equal the, and then, oh, yeah, and the social quantity. So that's a tax, and the very efficient. Is Q posted. So let's just do that. 2 times 10 plus T equals so what do I get? Of course, that if you didn't answer this just with the question D, that's I didn't expect anybody to. So this is just surplus. So yeah, 10. So 60 minus 30 minus 20. So that's so T equals 10. So the unit tax of T. So it's yeah, it was a bit higher than 1, but yes. And so what this means is here we're going to have this 30 minus so that's here, that's per V20. And that would be that's we haven't talked too much about taxes. But one thing you may note, so I'm anticipating again, is that the tax rate has to be chosen very, very precisely. Because if I decided that the socially efficient level was not 10 but 3, then the tax rate would be different again. Well, and by the way, it's quite obvious that the tax rate has to be equal to the difference between the marginal social cost and the private social cost at the optimal level of 10. Yeah. Okay. This is so tax will be 1. And then another one would be another policy. Somebody has an idea before we go? What have you learned is useful, is efficient at reducing quantity exchange on market? It starts with a Q. Yeah, Q quotas. Good. Yeah, you have earned your freedom. And then quota of 10. And if you have a quota of 10, then the market participants or the producers are going to charge as high as they can for a quantity of 10, and that turns out to be exactly 30, which is exactly the efficient, the socially efficient price, as we have computed here. So again, that would be perfect. But yeah, it was not in the question to say how much, just some suggestions. All right, so we're yeah, over time, right? So by the way, so I can next time I can solve exercises again or move on with the material. Do you have a preference? Okay, so all right, let's do that. Solve more stuff. Okay, so somebody else agrees with you.